All right, so this is a good review from yesterday and the day before. We have Valerie training for an upcoming triathlon. She has 12 weeks to increase her swimming meters. Valerie swam 1,000 meters on her first week of training and decided to increase her meterage by 500 meters each week thereafter. How many meters will Valerie swim in week 12? All right, so did you use an explicit or a recursive formula for this warm-up? Explicit, good. Why can't you use a recursive formula? Recurse, I would need reverse, right? So I would need to know week 11 to get to week 12, and I don't know that. So we're not going to use recursive, okay? We are going to use our explicit. What is our explicit formula? There you go. Good. Okay, so this is what we need. We are looking for week 12, right? Do I know what she did in the first week? What did she do? 1,000 meters. All right, do we know what the difference was each time? 500. Do we know my N? Well, my N is 12, yes. So yes, it's going to give me, okay, there we go. So we're going to get A sub 12 equals 1,000 plus 500 times 11. Good. What is 500 times 11? 5,500. Add those together. What did she do on week 12? 6,500 meters. Good. So very straightforward. Here's my facts. Plug it in. Give me a number. Okay. Yesterday we kind of went backwards a little bit where I didn't give you all the information. You wrote like the general equations for information given, so that way you could find anything. Okay. Today we're going to switch it up a bit with our first term. Okay. So let's remember some stuff. It is arithmetic. A system is arithmetic, right? If there exists some real number d such that each term in the sequence is the sum of d in the previous term. Again, this is very fancy for what? What makes it arithmetic? Addition. What does that mean, though? Or subtracting what? The same exact thing every time. Good. If you just say addition, I could add 1, add 2, add 3. That's not true. Okay? Has to be the exact same thing every single time. Also, our explicit formula we just used. And our recursive formula is when I use the thing before to move forward. Okay? So this is day 3 of using these formulas. All right? We are going to switch up our first term today. I know. Why? It actually is going to make things a little bit simpler. Yep. A little bit. We got this? So what if, so we've always had our first term be a sub 1, right? However, sometimes we should let our first term be a sub 0, okay? So let's look back at our word problem yesterday with Hans to see how this could have also been written with our first term being a equals 0. So we did this yesterday. So if we let a sub 0 be the first term, what is technically the value of n? Then n is going to be 0. Oop, too far. If we let the first term be a sub 0, what are we going to represent as the second term? If a0 is our first term, what am I going to use to represent the next term? A sub 1. Good, yes. Because we're moving to the next piece. So the value for n is 1. Okay, so we're going to keep that in mind when we talk about Hans. and his hourly wage. Ready? Here we go. Hans starts a new job. We did this yesterday. He starts off at $7.25 an hour. If he does well, he's on time, no complaints. He gets a 10-cent increase each quarter. Okay, so what was his starting hourly rate? The $7.25. Good. If he did a good job, he got 10 cents per added per hour per quarter. So what is his new hourly rate if after the first quarter he did well? $7.35. Good. We added the 10 cents to it. Assume he did well for an entire year. We're going to represent each piece. We did this yesterday. So notice here we start at n equals 0. Then 1, then 2, then 3, then 4 to represent an entire year. Okay. Yes.
Why do you only go a percent from the third quarter to the fourth quarter?
Oh, I don't. That should definitely be 65. Yep, you're right. Let's fix that. Thank you. Thank you. All right. Okay. So should we use a sub 0 or a sub 1 to represent our first term in the sequence? This time we should use a sub 0. Why? Because I haven't had my first quarter yet, right? In this situation, a sub 0 shows the very beginning without any change happening yet, right? N equals 1 means I've had 1 quarter pass by. N equals 2 means I have had 2 quarters pass by, right? So it does represent something a little bit differently. So in this situation, we should use a sub 0 for my first term, what he started with before I did anything else to it. All right, so because of that, our explicit formula is going to change a little bit. Now we're going to use a sub 0 plus dn. So we can write it as $7.25 plus the 10 cents an hour. Our recursive formula should look the exact same as yesterday. So yesterday we had n minus 1, right, in my explicit formula. Now I don't. We talked about why we had the n minus 1, because the first term was already in there and we couldn't count it twice, right? Because we had a sub 1 times d, or plus d times n minus 1. We did that to not count that first term twice. Here is a sub 1 being counted twice. No, it's not there yet. So here we just do times n. How many terms have happened since the very beginning? Okay, because we haven't included it yet. What kind of function did we say all of these were yesterday? They're all linears, which are lines, right? What's the equation of a line? Y equals mx plus b. Doesn't this look a whole lot more like mx plus b? What if it was written like this? Oh, hold on. What if I had this? Does that look more like a line with a slope and a y-intercept? Yes. So that's what happens when we have a sub 0. It looks more like the line. So that's why I actually like it better. Okay. So there were 2 different ways that we can write the explicit formula to make it different from a sub 1 and a sub 0. Okay. If we have my first term of a sub 0, my explicit formula is now a sub 0 plus dn. It looks more like that line format. Okay. If my first term is being written as a sub 1, then we have to do a sub 1 plus d times n minus 1. We can't use that first thing twice. We can't use a sub 1 twice. My recursive formula isn't going to change at all because I don't need a first term for the recursive formula. Okay? So we got options for our explicit formula now. Sometimes it's going to be better to use a sub 0. Sometimes it's better to use a sub 1. Sometimes the choice is yours. Sometimes it's going to tell you which one to use. All right, let's do an example. Here, we have an arithmetic sequence of 1/2, 3/4, 1, and 5/4. Okay? It says write an explicit formula to find the nth term of the sequence. So did it tell me to use a sub 1 or a sub 0? No. This question gives us options. We can choose how I want to represent it. Okay? Either way, though, I have to know what my difference is. I know you don't love fractions, which is why we keep using them. How does 1/2 change to 3/4, change to 1, change to 5/4? We're going to add 1/4. Well, we're not adding 1/4. Just kidding. Oh, yes, we are. Yes, we are. Yes, we are. Ignore me. Sometimes it helps to convert these fractions into decimals. Okay? So 1/2 is the same as 0.5. 3/4 is the same as 0.75. Then we have 1. This is 1.25. So our difference is 0.25, which is also written as 1/4. Okay? So that's the information we got to figure out from my sequence. D is 1/4. Now, if I use a sub 0 as my first term, then I just need my first term plus my difference times n. So I have 1/2 plus 1/4 n. If I use a sub 1 as my first term, then we go back to what we did yesterday. My first term plus 1/4 times n minus 1. Okay. Again, I do prefer this one just because I think it's simpler. I think it represents a line better. It makes more sense in my brain about how these are working out. Starting with something and then having a constant change afterwards. But if it does not specify which one to use, you have a choice. Okay. Or sometimes you don't have a choice, like this guy. We have an arithmetic sequence where a sub 21 is 10.2 and a sub 25 is 11. And the first term of the sequence is a sub 1. They don't tell us what it is, but they're telling us to use a sub 1 this time. Okay? So, first thing it wants us to do is find the common difference. Okay? So I've gone from step, A21 to A25. So how many terms have I gone through? We've gone through 4 terms, right? And I went from 10.2 to 11. How has that changed? I've gone 0.8 in 4 steps, right? So if I've gone 0.8 in 4 steps, what was my common difference each time? 0.2. Y'all get how we did that? It's really like the slope formula. Distance in y over distance in x or whatever. 25 minus 21. My difference was 0.8 in 4 steps. That's how we got the 0.2. So again, these all relate to lines, right? So it makes sense that I can use a slope formula to find my difference. That's what it is. All right, let's write a recursive formula for the sequence. Remember, recursive formulas, all we need is a difference, right? So a sub n equals n minus 1 plus d. What's my plus d? The plus 0.2. All right, before I write my explicit formula, I gotta know which term to put in there. What do I have to know for my explicit formula? Not the previous. The starting term. We have to know our starting term for the explicit formula. We got to know where we start. We already know how we move, but I got to know what is a sub 1. So we're going to use our explicit formula to actually solve for that missing piece. Okay, so let's find the first term. Let's do it. So we are going to use our explicit formula. A sub n, we actually have two choices. We could use a sub 21 or we could use a sub 25. Which one would you like to use? 25? Sounds great. So if I use a sub 25 equals, I don't know my first term. What's my n value? We picked 25. Yep, minus 1. And then what was my difference? The 0.2. All right. What is a sub 25? We know that value. What is it? It's 11. So I can say 11 equals my first term plus, I'm going to make that what, 24 times 0.2? What is 24 times 0.2? Come on, kids. 24 times 0.2. 4.8. And what's my final step in figuring out my first term? Yeah, subtract my 4.8. And what's my first term going to be? 6.2 is going to be my first term, my a sub 1. You get 6.2. So now can I write my explicit formula? I got all my information. Good. And they gave me a sub 1, so we need to use a sub 1 plus d times n minus 1. They told me which my first step is going to be, so we have to use that to fill in my missing pieces. There we go. It's prettier. Questions? Okay. What if it was a sub 0? Well, I could actually convert this. I could distribute and simplify to get it in that mx plus b kind of looking format, and that shows if it was a sub 0. Okay, it told me a sub 1, so this would be the appropriate answer, right, for using a sub 1. But if it wanted me to convert it, if I had a sub 0, I can distribute and simplify to show what it would look like as a sub 0. So I can go back and forth between the two. All right, a couple more. We got this. We're going to do some more converting. All right. I am giving you a recursive formula. So I've given you recursive right here. It wants me to rewrite this as an explicit formula. Well, what do I need for explicit? First term and difference, right? It has given me my first term, right? A sub 0 equals 12. It's also told me which format to use. Because I have a sub 0, I know I have to use the a sub 0 plus dn format to write this explicit formula. All right, so I have my a sub 0. We're good there. A sub n equals 12 plus, what is my difference? How can I find my difference? You can do it. Look at that recursive formula. Recursive formula, guys. You take the previous term and add the difference to it. So what was my difference? Negative square root of 2. Right here. N minus 1 plus d. Well, my d is negative square root 2, so my difference is negative square root 2. So we plug in our information that we have. Here is our explicit formula. When we have a sub 0, and we find our difference from the recursive formula. Okay. Why does it specify when n is greater than or equal to 0? What formula did we use it for? We used it for when a sub 0, right? It told me n can equal 0. Whoop, go back. So that's why we're allowed to have n equal 0, okay? Because that specifies that we're using the a sub 0 formula. All right, next one. Convert this recursive formula to explicit. Table people, talk, go. This one's you. All right, check your answer with mine. This time we have -5 plus 1/3 times n minus 1. How is this one different from the one you just did? We have an a sub 1 this time. A sub 1, which means that I used the different formula. It told me a sub 1. There we go. Where n is equal to... Actually, this one should not be equal to 0. Because we're representing above 1. All right. Now let's go the other way. Let's go explicit to recursive. Okay, so they've given me an explicit formula, 16 minus 2n. Okay, so 16, is that a sub 0 or a sub 1? A sub 0. What is the -2? That's our difference. Good. Which one of those pieces do I need, one, both, none, to write a recursive formula? I only need the difference. I only need the difference. So a sub n equals a sub n minus 1 plus, or I guess it's really going to be minus 2. Like that. Okay, for recursive formulas, all you need is the difference. Because recurse reverse, we use the one before to move forward. All right, you have another one on your paper. That's not up here for some reason. A sub n equals 5n minus 25. All right. There you go. Change this explicit formula to a recursive formula. Table people, go. All right, so I heard some light bulbs go off. How is this one a little bit different from the last one? It is switched around. Yeah, doesn't that look more like a line? That mx plus b situation? So from here, what is my first term? The -25, and what's my difference? The 5. This is my d. This is our a sub 0. Okay. Which one of those do I need for my recursive formula? Just the 5. So a sub n equals my previous term, and then plus 5. The end. Okay. So going from explicit to recursive, all you need is the difference. You got to make sure you know where the difference is. Okay. Remember, difference, think of slope. How you're changing, how you're moving. Okay, what you're adding on each time. All right. Here we go. Find the common difference of this arithmetic sequence. We got something different happening. They're not just numbers anymore. A sub 23 is 6a plus 7. A sub 25 is 2a plus 1. Table people, go. Table people, you can do it. All right, let's talk about it. I bet you either answered B or you answered D. I bet you it was one of those. Let's look at the difference. How did 6a become 2a? We went down 4. Good. How did 7 become 1? We went down 6. But this is not the answer. How come? What do you mean by simplifying? What do you mean? Because it went, there we go, I heard it. We went 2 spots from 23 to 225. This happened within 2 terms. So divide it by 2 because your difference happened twice to get there. So that gives me the negative 2a minus the 3. So that's why D is our answer. So again, very much slope. Slope way of thinking. How did it change? Rate of change. Difference here was it happened in 2 spots, not just from point A to point B. It went from point A to point C. It jumped over. We good? We okay? Maybe. So like an Algebra 2 setup with like an Algebra 1 skill attached to it. All right, this lovely is a thinker. Here we go. Given the recursive formula for an arithmetic sequence, a sub n equals a sub n minus 1 plus pi. Stop right there. The recursive formula gives me what? Gives me what? Gives me the difference. So tell me, what is the difference? I already know it. It is pi. I already know difference is pi. All right. Where the first term of the sequence is negative 3. Which of the following could be an explicit formula for the sequence? Okay, so tell me the first term is negative 3, but don't we have 2 options for that? That could be a sub 1, right? Or that could be a sub 0. So knowing that, table people, go. Which one of these could represent an explicit formula? Remember, we got 2 options now. We got 2 options. So we should have 2 checks going on. Okay, so what were the 2 different equations I could have? So what if my negative 3 was the representing a sub 1? What does that equation look like? A sub n equals, tell me.
Negative 3 plus pi times n minus 1.
Plus pi times n minus 1. Good. What if my negative 3 represented an a sub 0? What would that look like? Negative 3 plus pi n. Good. Do you see those as options anywhere? Is it my first one? Nope. Second one? Yes. Third one? Possible. Fourth one? Nope. Fifth one? Possible. Last one? Possible. Okay, so this guy and this guy, the difference is what n is allowed to be. Okay? That was the explicit formula right here when we used what for my first term? A sub 0. So can n equal 0? Yes. So which one of those is the correct choice? The second one or the last one? The second one. Good. This guy, because this is representing when I use a sub 0 as my first term. That's the explicit formula when it's a sub 0. All right. Here we go. Now we have, so this one's gone, right? Difference between this guy and this guy, again, is if n can equal 0 or not. Well, this is the explicit formula if I use what for my first term? A sub 1. So is n going to equal 0? No. So we want this guy. Like that. Here. So n has to be bigger than 0. Here, it could be 0 or bigger. Good. Beautiful. Okay, your notes are going to be your best friend when it comes to your worksheets. Okay, keep your notes right next to you because we did an example of every single one of these on our notes today.